Hello, and welcome to Eyes on Success, a weekly program covering a wide variety of topics of interest to people with vision loss. I'm Nancy Torpey.
And I'm Pete Torpey.
Enter Maxima Open Source Computer Algebra System 5.45.1.
As Jaws indicated, that is Maxima, an open source computer program for doing symbolic mathematics. I first started using it almost 40 years ago.
We'll speak with Robert Dodier, one of the developers of Maxima, about the capabilities of this free open source program. And also, towards the end, Pete will do a demonstration of how Maxima can be used with JAWS. But first, for our tip of the week. This week's tip comes from Robert Dodier.
The one thing that I would say about the community of developers and users that are centered around the mailing list, which we'll talk about in a moment as an important resource, I would say that one doesn't have to be an expert about computers or mathematics or computer mathematics, but rather I would say that anybody who is, basically anyone who is interested and has something that they want to share or a question that they want to ask, that people are welcome in that sense. And that it's not a closed community of people who are all knowledgeable about the same thing, but rather that it's really, and this is absolutely one of the important considerations for me as to what's interesting to me about working on this project, that it's an inclusive community that includes a lot of people who are not necessarily experts in the things that we're working on.
There's a role for everybody in these community organized projects, I think.
That's right. It's very much a community project in the sense that there isn't any one person who is stating the direction and then other people are following the lead, but rather that everything that happens is something that people feel inspired to do, or people have discussed and agreed upon, but they find the motivation and direction from within themselves for that. And to me, that's a very comfortable and productive working environment.
And the Maxima email forum is a great way for people to learn about Maxima and get help with Maxima. But hopefully the rest of this show will be a good introduction for those interested in symbolic math, using it for both students and professionals.
You are listening to Eyes on Success. Success, 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 success.
Let's start by meeting Robert.
Hi, I'm Robert Dodier, and I'm a Maxima developer and project administrator. And my day job is working as a software developer and staff scientist at the Oregon Health and Science University in the biomedical engineering department. I started off as a Maxima user almost 20 years ago and got involved in the project.
Now, Maxima these days is an open source, community-driven program. Is this just kind of a fun project for you, or do you actually do this as part of your job?
I do use Maxima at work, but the software development that I do on Maxima is on my own time.
Most of our listeners have visual impairments. Do you?
I'm nearsighted.
So you don't use any special adaptive tools when you're working with Maxima or anything else?
No, I don't.
Well, Pete does, so.
And I've actually started using Maxima probably about 40 years ago.
Oh, is that right?
Believe it or not, in the early 80s, yeah.
Eyes on Success is made possible in part by our corporate partners. Underwriting pairs the impact of targeted marketing with the integrity of community goodwill.
Learn more by sending an email to hosts@eyesonsuccess.net.
This week's focus topic is the Maxima computer algebra system, of which Robert Dodier is one of the developers.
Robert, today we wanted to talk to you a bit about Maxima and what kind of tool it is, and about computer algebra software programs in general and what they do and how they can be useful to particularly people with visual impairments. But Before we get into the details, can you tell people what Maxima is in general? Give them a brief overview?
Yeah, Maxima is a system for symbolic and numerical calculations. So I think people might be more familiar with numerical software that's adding numbers together automatically and maybe adding a long list of numbers more than what a human could do easily, and basically automating those arithmetic operations.
That is certainly more common.
But another kind of math operations that people need to do is to do algebra. So if you say things like, if you have a number and you add that number to itself, it's equal to twice the original number. And if you don't specify what that number is, then you have a variable floating around, often called x in math notation. And working with variables that don't have definite quantities or numerical values assigned to them is in the realm of computer algebra. And it turns out that this is not too much harder to do than the numerical calculations, but it's considered a more specialized topic.
What are some of the other more common symbolic manipulating programs?
Well, there's commercial systems such as Mathematica or Maple, and then other open source systems. There's one called Sage. And so there's probably on the order of a half dozen systems or so that are still in active development.
And Maple is a commercial program that I
That's
used
right.
to do symbolic math later on in my career at Xerox. And it has much the same functionality as Maxima, but being a commercial program, there's more documentation and there, some slickness to it.
Right.
So tell us a little bit about the history of these programs, and Maxima in particular. I first ran into it. It was used on a mainframe computer that I was time-sharing from Rochester all the way up to Boston over a phone line. But I assume Maxima was available before then.
Right. So it started in 1968 as part of a larger project at MIT called Project MAC. And the letters MAC stood for Machine Aided Cognition. And so Maxima at the time was considered to be part of what was, in the larger sense, considered artificial intelligence at the time. And development continued on at MIT as part of Project MAC for several years. But that project came to an end in about 1982, I believe. And in the 90s, open source had become a term that was widely understood. And so I joined the Maxima project in 2003 when I was wanting to calculate some integrals for statistics. And I was looking around for ways to do that. And that's how I found Maxima. And we've been continuing active development ever since then.
Over the years, I've seen Maxima spelled a couple of different ways. I assume that's tied into this history?
That's right. That's right. So the original spelling was MAC, like Project Mac, SYMA.
Like symbolic algebra.
Right, symbolic math, right. And that spelling was maintained. I didn't talk about this, but there was a commercial variation of Maxima in the 1980s. But the open source project, in order to make it distinct from the commercial project, named itself Maxima, MAXIMA. So it's obviously a different project.
And that's its current incarnation.
That's right, Maxima with an X.
Now, you mentioned in your description of some of the history, the word integral. And in the beginning, we talked about it being a computer algebra system and symbolic math. But it actually does much more than what people would consider algebra, like x plus y equals z. It does a vast array of sophisticated mathematics. Can you kind of give an overview of the kinds of capabilities and functions it has for higher mathematics?
Yeah, so I think that Maxima is a really good intersection between symbolic math and numerical math. So when I solve problems a lot of times there's a numerical aspect to it where I have to add numbers together, different operations. And then there's also a symbolic aspect to it. And sometimes those aspects are kind of tied together. And I think that the general scope of the capabilities of Maxima is approximately undergraduate mathematics, of the kind of math that one would study at college, such as calculus and linear algebra. And then there are actually a multitude of additional packages which are devoted to specialized topics.
And what interests me about some of these computer algebra programs, particularly for people who are visually impaired, is, it's difficult for me to work with pencil and paper because I don't see what's on the paper. But using these programs, it's possible for someone who is totally blind to perform these sophisticated mathematical calculations symbolically and then also numerically, as you pointed out.
Yeah, I myself don't have any experience with that. And so I look forward to hearing your synopsis of that, Pete.
So what I've generally found is a lot of these programs have a very sophisticated user interface, graphical interface. And mathematics, as most sighted people will know, is very two-dimensional in how it's laid out on the paper. But that isn't really appropriate for people who are blind because they're either reading things line by line on a computer screen or using a refreshable braille display that only has 40 or 80 characters on a line at a time. So one of the ways that I use these symbolic manipulation programs like Maxima or Maple was to use the command line interface. And there are commands in any of these programs to output the mathematical formulas in a one-dimensional view rather than a two-dimensional view. So I've seen it works reasonably well in the console version of Windows, and I presume Mac, but I haven't worked with a Mac computer. So I can navigate through the history of commands and input new commands. So if I'm working on some mathematical expressions, I can go back and forth, change the expression, solve equations. If I didn't like the answer, solve it a different way. And so it's quite powerful.
Right. So the iterative process with working with Maxima is something that I make use of all the time. Basically, I end up, setting up a problem and solving it and then thinking about it and then thinking, oh, well, there's this aspect that needs to be different. So I'll go back and change the inputs and then I'll try solving it again and it changes the answer. And then I look at that and think about that. And Maxima is a very comfortable environment for that kind of repeated trial and error solving of equations and working with different kinds of mathematical expressions or operations.
And that's good because that's often the way scientists solve problems. If you knew the answer ahead of time, you could just solve the problem straightforwardly, but often it takes a little messing around.
Right. It's very much a process of figuring out what the question is before you can answer it.
Now, I haven't done this, but I assume that a blind person can work in the command line view in their most comfortable format so they can understand the input and output. But I presume that you can also then change the output to its two-dimensional format. So if you wanted to share it with sighted colleagues or sighted peers, that would be a nice thing to do.
Right. I believe that is indeed possible.
And also, if people are doing very repetitive tasks, I think you can also write your own kind of subroutines to which you can refer later on.
That's right.
So it's very sophisticated. It's like its own programming language, or you can use it a line at a time if you want. There's a lot of flexibility there.
That's right. Maxima includes a programming language.
So I'm going to give a short demo using Maxima with a screen reader in just a bit so people understand how it works. But just to help people get started, can you give them some hints how the help system works or some kind of quick tips? What's important to know at first when you hop into it without knowing anything?
The first thing that mystified me was that Maxima allows you to separate the input over multiple lines when you type it in.
Mm-hmm.
And so to tell Maxima that you're done typing in an input, you have to put a semicolon. Otherwise, it doesn't know you're done. So I was mystified the first time I tried to use it, that I typed something in and pressed the enter key and nothing happened. So that's a hint that I think everybody should have to start with. So about the help system, there's both a online help system where you can type a question mark and a space and the name of a function, and then it will tell you the information about that function. And also that the help documents are also available as HTML pages.
So there's a good user manual that comes along with this to which people can refer, or they can get quick help just by entering a question mark followed by a space and a command.
That's right. Yeah, the reference manual is quite extensive.
Now you have quite an active email forum that I see. What is the work still going on with Maxima?
Well, the main topics of discussion are between fixing bugs and also solving particular problems, and finally sorting out new features.
And just to be clear, much as we talk about the bugs, as any software program probably has bugs these days, this program is perfectly well suited for undergraduate mathematics, even mathematics in a professional realm, so people shouldn't be shy about using it to get some real meaningful results.
That's right.
You know, when kids are young and they're in high school or starting college and they're blind, if they don't know about these tools, they can be really intimidated by even considering a career in science, because, you know, mathematics is intimidating enough.
Yeah.
But if you know these tools exist, and so that's kind of our point here, is to just let people know these things do exist and they can be used.
Yeah, that's great.
Well, and even if somebody isn't using it to do advanced mathematics, just using it to read the equations to them, I'm sighted. And I've tried reading mathematical equations to Pete, and I auditioned for what is now Learning Ally. Failed the audition. It's difficult to read an equation or a formula in an unambiguous manner.
Right.
But these mathematical manipulators, they do that. That's just part of their core process.
Yeah, I think that, you know, now that you mention it, I think that kind of a unsolved problem probably is that when I look at mathematical equations, they have a certain form to them, like a large-scale organization that kind of indicates the larger question of what's going on, and then you can look at pieces of it to get the details. And probably that kind of, you know, large-scale, small-scale change of focus is probably hard to automate, but that's probably a direction that could be useful to people.
Yeah, and programs like this are great for that. When I had large, complicated equations with lots of sub-expressions, I would let one sub-expression be A and one be B, and so I could understand sort of the global perspective of the equation. But then I could also look at what was the A expression, what was the B expression, and it gives you many options for manipulating these types of expressions. And then the other thing, as we pointed out, is once a blind person has coped with all the mathematics and expressions on their own terms, they can print out a version that is readable by sighted people in the format they're used to seeing things.
Right. Something that occurs to me is that I think that on the whole that the Maxima community is not very aware of the issues around how sight impaired people would be using Maxima. But if we knew more about what's needed and how people could be using that, then I think that could be a good inspiration for some additional development to happen.
That would be cool.
Well, yeah, hopefully we'll encourage more people to try it out. These programs are very useful to me in my professional career at Xerox.
Great. I'm glad to hear it.
Yeah.
Well, thank you very much.
Thanks a lot, Robert.
Yeah, you bet.
And as promised earlier in the show, here's Pete doing a demonstration of Maxima using JAWS.
If you're using Maxima with a screen reader, you'll want to run Maxima in the command line mode instead of the graphical mode. In Windows, I'll do that by entering into the Windows search Maxima.
Maxima left parent command line right parent.
And hitting enter.
Enter. Maxima open source computer algebra system 5.45.1.
And Maxima just started. Now, if I look at where my cursor is,
left parent %I1 right parent.
It says %I1. So it's waiting for input, and this indicates this is the first input line. Input lines are labeled this way, %I1, %I2, %I3, etc. And similarly for output lines, %O1, %O2, and you can refer to those in later statements. So let's see how Maxima works. If I type in x plus x.
X plus space x.
Remember, I have to put a semicolon before I hit enter to have that statement executed.
Semicolon. Enter. Left parent %O1 right parent 2 star x. Left parent %I2 right parent.
And I get 2 times x, which is x plus x. So that shows you how Maxima does symbolic math. And I'm now at the next input line, %I2. Now, when you're running Maxima with a screen reader, you'll want to set the variable display2D to false. And the way you set a variable in Maxima and assign a value to it is to type a colon. So I'll type in
display2D, colon, false.
And remember the semicolon.
Semicolon. Enter. Left parent %O2 right parent false. Left parent %I3 right parent.
Now, what this means is if I didn't do that, it would display all the output in a two-dimensional format that sighted people are used to seeing. For example, if I'm writing x squared, it will put a 2, and then on the next line under that, it will put an x. And that's not an easy way to read things with a screen reader, so I'd like everything on one line. I'd like to see that as x caret 2. Now, if you go to the notes associated with this show, I'll have instructions for using Maxima with a screen reader and setting up some of these things so you don't have to type it in each time. You can put these values in an initialization file, but we don't have the time to show that now. Now, another interesting thing of using the command line version in Windows is that you can get into marked mode. And the mark mode you get into by hitting Control M.
Control M.
And now you can use your arrow keys to arrow up and down or page up and down to review what previously was displayed on the screen, because sometimes things will display off the screen if you're running a long session. So I can use my arrow keys to go up.
Left parent %O2 right parent false.
That shows me the result of setting my display 2D to false.
Lang. Left parent %I2 right parent display 2D colon false semicolon.
There was the input line where I typed in my statement.
Left parent %O1 right parent 2 star x.
And that was where the output line was written when I added x plus x. To get out of mark mode, I hit escape.
Escape.
And if I look at where I am,
left parent %I3 right parent,
it places me immediately at the next input line. So that can be very useful. Now, one other useful thing to know about getting help in Maxima is that you can either hit one question mark followed by a space and then the search term you're looking for, but then you have to have the exact term, or you can type 2 question marks followed by a space and something similar to what you're looking for. So let's say I wanted to work with matrices. I'll type
question, space. Matrices, enter. 0 colon functions and variables for matrices and linear algebra. 1 colon introduction to matrices and linear algebra. 2 colon add matrices left parent functions and variables for linear algebra right parent. Enter space dash separated numbers. Grov all or grov none colon.
Now what happened there was Maxima output a list of help topics that I might want to read. So if I type in 0 and then enter, I'll get that help topic. If I hit 1 and then enter, I'll get the next help topic. So let's do that. I'll type 1.
1. Enter. 23.1 Introduction to Matrices and Linear Algebra star menu colon star dot colon star matrices colon star.
And I'll stop speech there, but basically what happened was it's displaying the entire help topic about matrices and the different functions that can be used with matrices. So again, either question if you know exactly what you're looking for, or question, each of those followed by a space for some other term you're looking for help for, and then you can find the particular topic in Maxima. Now remember, I showed you just a very simple example of adding x plus x. I showed you how to get help, but Maxima can do much more complicated symbolic math. You can solve differential equations, you can take derivatives, you can take integrals, solve simultaneous equations. There are lots of useful features in Maxima for anybody who would like to go into mathematics and do symbolic math. And, of course, Maxima can also do numerical calculations. So there's a quick introduction to using Maxima with a screen reader, and that should get you started.
You are listening to Eyes on Success. Success, 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 success.
Now for this week's final item, how to learn more about Maxima and how to contact Robert Dodier directly.
Well, Robert, if people are interested in obtaining Maxima and trying it out, and they're interested in some resources to figure out how to use it, where would you direct them?
Well, the Maxima project is hosted on a website called SourceForge, and the project website is maxima.sourceforge.io.
And that's Maxima these days.
That's right.
Okay.
That's right.
And if people are looking for other resources and how to use Maxima, if they have questions, I often use Google, but maybe you have some other pointers.
Well, I think that the best resource for getting help, aside from the documents and other materials on the website, I think that the best resource is the mailing list. So the mailing list comprises the developers and also people who are using Maxima. And that mailing list is called Maxima-Discuss.
And if people had questions for you, can they contact you through the forum, or do you have another email address that's appropriate?
If it's a question about Maxima, I recommend the mailing list, Maxima Discuss. And personal emails can be sent to me. My email address is robert.dodier, Dodier, @gmail.com.
And of course, we'll have all of that contact information in the show notes associated with this episode at www.eyesonsuccess.net. We'll also have some notes on getting started with Maxima with a screen reader, as well as some other resources in the show notes.
That's it for show number 2138. Next week on Eyes on Success, we'll be talking about using Reaper with Osara. Reaper is a multi-track audio production program that's used by many people with visual impairments. Osara makes it possible to do that by making it accessible on PCs and Macs. We'll speak with Scott Chesworth, who manages the Reaper forums, and Jamie Tay, who created Osara.
And I actually started using Reaper a little less than a year ago to edit the Eyes on Success podcast. So tune in next week for that episode.
You've been listening to Eyes on Success, hosted and produced by Nancy Torpey and Peter Torpey.
You can access the full archive of previous shows, subscribe to the podcast, and much more by going to our website, www.eyesonsuccess.net. If you have questions about anything you've heard on the show or have suggestions for future shows, send an email to hosts@eyesonsuccess.net.
Thank you for listening and have a nice day.